Oh no, my Pook cell. So I've got a couple of these things, and I want to find out how many you need to power an entire desktop gaming setup. Not only do I want these tiny little batteries to power an entire desktop gaming computer, but also all of the peripherals and a monitor. If I manage to successfully power this computer, I was also thinking, maybe we throw in a graphics card. And if that works, a good graphics card? Let's see how far we get with just the computer first. There's no case, but this is a regular desktop computer, and it's notably lacking in AA battery slots. That is not going to work. So how do you connect AA batteries to a computer power supply? I don't know, I'm not going to. The whole point of this box is to take high voltage AC input and convert it to low voltage DC to run the computer. It just so happens that a AA battery outputs low voltage DC. We don't need this. Replacing this whole box is this little AliExpress cable. This has a standard ATX power supply plug that fits onto my motherboard, and then it just passes through whatever 12 volt DC you apply to these wires. Modern desktop computers primarily draw 12 volt power. Now, they do technically also need 5 volts and 3.3 volts to function, so there are some voltage regulators on here to make those other ones. But they don't need to be that significant. Mostly, it needs 12 volts. So then, we just do this. Except AA battery is not 12 volts, it's 1.5. We're gonna need more. 8 AA batteries should give me 12 volts, and I've 3D printed some battery holders. I wanna find out if this works. Let's connect AA batteries to a desktop computer. I'm reading 13 volts on these 2 wires, which I will now plug into the computer. That's interesting. It immediately dropped down to 12.5 and the light on the motherboard is on. One more thing, I'm going to add this meter to show the current drawn from the batteries. That way we know how much power we're actually using. And I have to say, this is not inspiring confidence. We're drawing 0.06 amps, and that's enough to drop our 13 volts down to 12.4. I kind of feel like as soon as I press the power button, it's just gonna do nothing. Only one way to find out though. Yeah, that didn't do very much. The fan moved a little bit. That's cool, I guess. I'll have your 8 batteries, and then I'll have 8 more batteries. Yeah, that still does nothing. How about 24 batteries? I'm out of batteries. I spent like 4 hours building these battery packs. This was a stupid idea. Well, I can't just give up now. Did you know there's multiple kinds of AA batteries? There's flavors to these things. One of these batteries is a carbon-based battery and one of them is an alkaline battery. And they're useful for very different things. Both of these batteries are designed to output around 1.5 volts, but their output current capabilities vary dramatically. Short circuit current on the carbon battery, 2.6 amps. Now let's try the alkaline battery. 3.7 amps. Alkaline batteries are both higher capacity and can output more current. The only really advantage of a carbon battery is that it has a longer shelf life. So if you're gonna power like a TV remote, for example, you might get longer battery life out of a carbon battery because this draws very, very little power. Right away with the alkaline batteries, higher starting voltage, even with only one set of batteries. All right, we gotta try it. Power on. No, it's not working. Every time I hit the power button, the battery voltage drops, and then the computer just dies. We're not making very much progress. I have a feeling we're going to need a lot more batteries. I don't know how good Pook cell build quality is. A lot of the negative ends of these batteries broke off when I dropped them. I was in the process of connecting more batteries when I started thinking, these wires I'm using are really thin. When you combine that with the computer's power draw, it's not consistent, it comes in spikes. I think a lot of our voltage drop is coming through the wires rather than the actual batteries. To help with this problem, I added 2 big capacitors right near the power input to buffer those spikes. And I also wire the batteries in a way where there would be no single wire powering the entire computer. Instead, it'd be spread apart across like 3 or 4 of these things. I decided to just kind of go for it here. This is 56 AA batteries. Right now, the computer is being powered by this power supply. The plan is I'm going to connect all these batteries to my capacitors. That feeds the computer, and then I'm going to disconnect this power supply. And hopefully the computer keeps running. Okay, first set of batteries. Everything's connected. I'm gonna unplug the power supply. We dropped from 13 volts to 11.3, but this computer is running off of AA batteries. All right, we gotta play a game to count this. Oh no, down to 10, under 10 volts. How is this still running? Why didn't I pre-open Steam? Oh, it's dead. So I tried again, but this time I got the game fully running before switching to the batteries. Currently in game, this game is running on this computer. I'm gonna unplug the power supply. I don't have confidence. Look at how much power is coming out of this thing. It's drawing 70 watts. All right, here it goes. Okay, I'm gaming. I'm gaming on batteries right now. That was short-lived. If I really wanted to say I played this game on AA batteries, I need to play it start to finish. Instead of making the power system better, I thought, maybe I can just make the game worse. If I can beat this level of Minesweeper, technically, I played a game powered by AA batteries using a desktop computer. Unplugged, 13 volts, let's start minesweeping. Minesweeper is really not a hard game at this level, but the pressure of knowing you have a limited time before your entire computer setup just shuts off, it makes it a lot more difficult. 10.3 volts, last 3 squares here. This has to be a mine, because it's near this. 2 around this, 2 around this. This has to be safe. Yes, I beat it. I beat Minesweeper on AA batteries on an x86 computer. Okay, save that score. Did it just die? I don't care, I saved the score. But I still lied to you. I said I would power the entire setup from AA batteries, not just the PC. I didn't plan this, but it turned out the keyboard and mouse I was using already had AA batteries in them, but my monitor did not. Power cable out of the monitor plugs into this bank of rechargeable batteries. And the Skit Fratty has power. Minesweeper Game 2, this time without lying about the peripherals. Computer is now on AA battery power. The computer just died. No. I did not make it, but I set up for one last attempt. So these are not rechargeable batteries, and I'm probably damaging them by doing this, but I turned the computer off, which means if I connect the power supply back to this, it will put power into the batteries. Yeah, there's 3 amps going into the battery pack right now. I'm going to get this time. Minesweeper is ready. Batteries are at 13.2. All right, unplug it. Gone. Minesweeping. I hate the ones that have 4. How am I supposed to figure that out? Okay, this is going really well. Down to 10.8 already. We're not even at 11 volts. I don't know how the computer even runs this low. This is a mine. This has to be a mine. This has 2. This is safe. That's got 2. 1. Yes. Save the score. We actually saved it. We saved the score. 10.4 volts. Completely on battery power. This was an amazing success. Oh, and the computer's dead. That was fast. This stupid computer needs all of this to run for a few seconds. The little Skit Fratty, it does not complain with this tiny battery pack. How much current does this even use? Okay, I dropped everything. It's actually more than I thought though. It was drawing about 0.9 amps, which is kind of quite a bit for AA batteries. It was doing it fine though. Never gave up until that situation. I also said I would attempt to power the computer with a graphics card installed. This is going to turn off and die so fast. Unbelievably fast. That's interesting. It's running now, but it didn't boot the first time. I wonder if it doesn't like we're hitting over 13 volts sometimes. I think that would be going straight to the graphics card, so I don't know, maybe it's a problem for it. Well, obviously the graphics chip isn't getting 13 volts, but the board itself, I think it would be. Graphics card installed. I'm running a 3D game here. It's just gonna turn off instantly, I'm pretty sure. All right, unplug. No, we're on batteries right now. Okay. How is this doing this? 9.7 and it's gone. All right. I mean, technically it powered the graphics card very temporarily. Good job, Pixels. Mission accomplished. I was also thinking though, if I used a more efficient computer than this, maybe I could beat a bigger game like Minecraft. Let me know in the comments if you want to see me try that. Thank you for watching and get subscribed for next week's video. If you like this one, maybe check out the one where I tried erasing hard drives using a microwave oven. That was interesting. Until next time.